All right, so you're in the middle of working on an activity that is exploring chemical bonding. And in order to really have a good understanding of chemical bonding and how chemists apply it, we need to have a good working knowledge of valence electrons and how they relate to the structure of the periodic table. And you also need to have a good understanding of how to draw representations of valence electrons, and that's what this short lecture is going to give you information about. Okay, so when chemists talk about valence electrons, they're talking about the electrons that are furthest away from the nucleus. So in this diagram that's shown here, recall that here is our nucleus, okay, and remember that there are protons and neutrons in the nucleus, and that these particles right here that are represented by these green dots, those are electrons. And actually they're represented by these blue dots as well. So that's an electron, and this is an electron. Okay, so the atom that is being represented here is carbon. Okay, carbon's atomic number is 6. Okay, and that means it has a neutral atom of carbon has 6 protons and 6 electrons. So this Bohr diagram is representing those 6 electrons, like the ones that you drew in class in the activity that we did. Carbon has 4 valence electrons, and that would be these 4. Okay. The valence electrons are important because they're the ones that are involved in making chemical bonds. And just so you remember, a chemical bond is an electrical force or attraction between two that links two atoms together to form a compound or a molecule. Okay, so you might have been wondering how you can figure out information about valence electrons from using the periodic table, and you actually can. The group numbers, remember group numbers are the 18 numbered columns, are useful to help you figure that out, because the ones digit tells you the number of valence electrons. So the ones digit in the group number is equal to the number of valence electrons. Okay, there is some variation for these transition metals because they can do some kind of funky things with their atomic or with their outermost energy levels, but good rule of thumb is that the ones digit in the group number tells you how many valence electrons there are. So in other words, if an element is in group 15, it has 5 valence electrons. If an element is in group 2, like beryllium, it has 2 valence electrons. Okay, so you should notice that if elements are in the same group number, they're going to have the same number of valence electrons. All right, so valence electrons are used to help us figure out the kind of chemical bonds that a compound might be held together by. And so we have a way that we need to represent them because we use them in what are called Lewis dot diagrams or Lewis dot structures or electron dot structures. And these diagrams all represent the same thing, and what they are molecular models for how chemical bonding might happen within a particular compound. The person who's credited with coming up with this idea is a chemist by the name of Gilbert Lewis. And he published this work in 1916, and he's really considered kind of the father of modern chemical bond theory. So we're going to be using these valence electrons in Lewis dot structures to learn more about chemical bonding. But for right now, we're just going to be learning how to make them for individual elements. So to make these for individual elements, there's some things that you need. The first thing that you need is you need the atomic symbol of the element. Second thing that you need is you need to know its group number, because remember the ones digit tells you how many valence electrons it has. And then there's a particular sequence that we use to make the dots around the symbol. So I'm going to show you that right now, okay? And I'm going to do this in a couple of different ways. So the sequence for the dots: 1 valence electron, 2, 3, 4, 5, 6, 7, 8. So 8 is the maximum number of valence electrons. Now, what I just showed you in this order was the sequence that we place the dots around. So really, when you're doing a dot structure, and again, X represents any element, but instead of using numbers, you'll use dots. So 1 valence electron, 2, 3, 4, 5, 6, 7, 8. And we draw them the way that we do so that we end up with a maximum number of unpaired electrons, because it's the unpaired electrons or open spots where a chemical bond can be formed. Okay, so we're going to go through some examples here of how to make some dot structures so you can actually see them. Okay, so remember there's a few things we need to know. The first thing we need to know is the atomic symbol of the element. Well, phosphorus is represented by a P, calcium is represented by Ca, and germanium is represented by Ge. Remember to pay attention to, again, how you write the atomic symbols. For the 2-letter ones, it's a capital letter followed by a lowercase. Okay, the next thing we need to know are their group numbers. Potassium is in group 15, so that means it has 5 valence electrons. Calcium is in group 2, so it means it has 2 valence electrons. And germanium is in group 14, group 14. So that means it has 4 valence electrons. Okay, so now we're going to actually draw these. So phosphorus has 5 valence electrons around it, so remember there's the order: 1, 2, 3, 4, 5. Okay, so phosphorus has 3 spots where a bond could form: there, there, or there. Okay, so we'll talk about that, what that means when we get into chemical bonding. Calcium has 2 valence electrons, 1, 2. Okay. And so calcium's got a bunch of spots where it could form bonds. And then the last one, germanium, has 1, 2, 3, 4. Okay? So what you should do after you watch this is you're going to continue in the activity and get some additional practice doing these on your own.